Okay, this basic math skills self-test number 2 is very similar to number 1. Same topics will be covered, and we'll use the same format. So just changed a few things, and let's see how you do. Okay, this self-test has 20 different problems for you to try. When you see a new problem, click on the stop sign to pause the video. Try to work the problem out on a piece of scratch paper or something. Then click on the go sign to start the video, and you'll see the problem worked out. Number 1, turn 0.720 into a fraction, then simplify your answer. Click on the stop sign. Okay, let's see how you did. Well, when you're turning a decimal into a fraction, whatever this number is, without any regard to the decimal, that's your numerator. So our numerator is 720. Just like if I had 1.2 as my decimal, my numerator would be 12 and my denominator would be 10 because I'm dealing with tenths. All right, so we'll take a look at this. My denominator will have 3 zeros in it because I have 3 places to the right of the decimal. So we'll come down here and we'll put 3 zeros and we'll stick a 1 in front of that. So that's the fraction that this decimal represents. However, we need to simplify this. So how do you simplify something? Well, you can factor it, and then you can cross out the similar factors that are the same factors that are in the numerator and the denominator. We'll take a look at this, and we'll say, first of all, 72 times 10 is 720, and 100 times 10 is 1,000. Well, I have a 10 in the numerator and I have a 10 in the denominator, so I can cancel them. They just become 1. This just becomes 1. And so I now have 72 over 100. And that's an equivalent fraction to 720 over 1,000. Okay, we'll factor this a little bit more. 72 is the same thing as 2 times 36. And 100 is the same thing as 2 times 50. So this is an equivalent fraction to this. I have a 2 in the numerator, I have a 2 in the denominator. It becomes 1, becomes 1. So now I have 36 over 50. 36 over 50 can be further factored. And we're going to factor 36 as 6 times 6. And then we're going to factor 6 times 6 as 2 times 3. So we'll go 2 times 3. 2 times 3 times 2 times 3, because this is 6 and this is 6. 6 times 6 is 36. That's completely factoring my numerator. My denominator, I can say, is 2 times 25, and 25 can be factored as 5 times 5. And that's as far as I can factor it. So now I have a 2 in the numerator and a 2 in the denominator. And then I have a 3, a 2, and a 3, so I can cancel this one, and I can cancel this one, and we have 3 times 2 is 6 times 3 is 18. We have 18, and 5 times 5 is 25, so that's 25. 18 over 25 is the simplified fraction of 0.720. If we were to do the long division problem of 25 into 18, we would come up with this same decimal right here. All right, let's move on to the next one. Number 2, turn 7/8 into a decimal. So click on the stop sign. 7/8 into a decimal. Let's see how you did. It's just a top in, bottom out kind of thing. So we'll put the top 7 in, and we'll put the 8 on the outside. Remember, 7/8, that's the same thing as just 7 divided by 8. And so this is the long division form. 8 will not go into 7, so I'll put a 0 here, and I'll add a decimal, which means that my answer is going to be smaller than 1. Well, 7/8 is smaller than 1. All right, I can add a 0 here now, and 80 will go into 70 8 times, because 8 times 8 is 64. So we have a 64 here. It's kind of the value of knowing your multiplication tables. And now we do the subtraction. So we wind up 70 minus 64 is 6. And 8 will not go into 6, but it will go into 60. 7 times. 7 times 8 is 56. Again, good thing to know your multiplication tables. We do the subtraction, and I wind up with 60 minus 56 is 4. And 8 will not go into 4, but it will go into 40 exactly 5 times, and that's a 40, and that terminates, and we're finished. So our answer is 0.875. And I put the 0 here in front so that cues anybody who's looking at this to know that it's followed by a decimal. Anytime you see a number starting off with a 0, you know that there's going to be some decimal that follows that. And so we'd have 0, 1, 1, and that would be the decimal 11 hundredths if we were to turn that into a fraction. Okay, number 3. Turn the decimal answer that you got for number 2 into a percentage. Remember, it was 0.875. So we have 0.875. You shift the decimal 2 places, and that gives you the percentage. So the answer here is 87.5%, because percent means per 100. So what this means is we have 87.5 out of 100. And if we were to do the long division process on this, we would come up with this answer here. This is the percent if we're dealing with hundreds. So that's why it's called a per 100, 87.5%. Number 4, all units are in feet. The rectangles are proportional. What is the length of x? Click on the stop sign. Okay, well, let's see how you did. They're proportional, which means that whatever we multiply this length by to get this length, we would multiply this length to get the same answer over here. They're proportional. So if we compare 3 to 7, then we have to compare x to 12. If we compare 3 to x, then we have to compare 7 to 12. If we compare x to 3, then we have to compare 12 to 7. Doesn't matter how you do it, you just need to keep things straight. So we're going to compare 3 to 7. So I write 3 to 7, and I compared 3 to 7, so I'm going to compare x to 12. And that's going to equal x over 12. Now what happens is if I cross multiply 3 times 12, that equals 36. And if they are truly proportional, 7 times x will also equal 36. So now I come down here and I say 7x. I want to find out how much x is, because that's what we were originally told to do. We were going to find out how much is x. All right, 7x does equal 36. How do I solve for x? Well, works like this. I come in and I divide both sides of my equation by 7. That keeps everything in balance. And so I now have a 7 in the numerator as a factor, and I have a 7 in the denominator as a factor, so they cancel, they become 1, and then I have 36 over 7. So what I really have now is x equals 36 over 7. And then I have to do the long division problem on that. So let's clear a space here so we can, okay. Now I'm going to do the long division that I have and need to do for top in, bottom out. So I have 36. And I want to know how many times will 7 go into it. Well, 7 times 5 is 35. So we'll put a 5 here, and that's 35. And that leaves me with 1 left over. And so I could put a decimal there, or I can turn that into a fraction. Let's get rid of that decimal. All right, so that leaves me with 1 left over, and I'm dealing with sevenths there. That's 5 and 1/7. And that's exactly what it is in feet. Or we could continue on and find out what it is in decimals. And so let's move this 5 and 1/7 over here. I have 5 and 1/7 feet. And we'll clean up this a little bit so we can continue to work. Alright, and take care of that. Add in a couple more things. Now I have 7. How many times will 7 go into 36? It'll go 5. That's 35. That leaves me with 1 left over. 7 will not go into 1. So I'm now down smaller than 1. So I come down and I can add a 0 here. 7 will go into 10 one time. And that'll leave 7. Do my subtraction. That will leave me with 3. 7 will not go into 3, but it will go into 30. And it'll go into 34 times. And so that's 28. There we go. Now I do my subtraction. That leaves me with 2. 7 will not go into 2, but it will go into 20 2 times. And so that's 14. And that leaves me with 6 left over. And you know, this could go on and on and on. So we're going to chop this off truncated after 3 decimal places. So x is exactly 5 1/7 feet, or it's approximately 5.142. It's not exact because I could continue doing my long division here and I'd get a whole bunch more numbers out over here. Alright, moving on to number 5. All units are in feet. What is the area of the larger proportional rectangle? Okay, this is the same drawing from earlier. Click on the stop sign and try to work it out. Now, let's see what you got. Well, remember, we had 5.142, I believe it was. Let's go back. Yep, 5.142. And the area for a rectangle is just length times width. So we'll stick in our x and y values here, and that would just simply be 5.142 times 12, and 5.142 times 12, we'll set that puppy up over here. I go 5.142, and that's feet, times 12 feet. So I just line everything up this way. I'm not giving any consideration to my decimal. I'll deal with that later. 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2. And 2 times 5 is 10. Now I come in and add a 0. And now I'm going to go 1 times 2 is 2. 1 times 4 is 4. 1 times 1 is 1. And 1 times 5 is 5. Add it all up. I have 4. I have 0. I have 6, 7. Carried the 1. See, this was 10. So I put a 0, carried the 1. That's 7. This is 1, and that is 6. Now I count the number of decimals that I have up here. 1, 2, 3. 1, 2, 3. And I have 61.704 feet squared. All right. If I were to approximate this, let's say I wasn't worried about the decimal here. It's just 5 times 12. 5 times 12 is 60. I'm going to have an answer that's going to be a little bit more than 60. And here I have it. The answer is a little bit more than 60, so I can feel pretty confident that my answer is correct and that I've handled the decimals okay. Number 6. The square root of 18 is between what 2 consecutive whole numbers? Click on the stop sign. Alright, works like this. Let's see how you did. First of all, consecutive just means that they come together on the number line, like 9 and 10. So we have 9 and 10, or 13 and 14. Those are consecutive numbers, and they're whole numbers. So the square root of 18. The square root of 18 comes between a couple of whole numbers, but what 2 whole numbers? Well, if we take a look at this, we go the square root of 16 and the square root of 25. The square root of 16 is 4. The square root of 25 is 5. So the square root of 18 comes between the square root of 16 and 25. And so it falls on the number line somewhere between 4 and 5. Number 7, triangles are proportional. What is the angle measure of the unknown acute angle? That one right there. Click on the stop sign. Okay, let's see how you did. Well, if these triangles are definitely proportional, and this right here means that it's 90 degrees, then that means that this is 90 degrees. If this is 28 degrees, then that means this is 28 degrees. So this is 28 degrees, and this is 90 degrees. And every single triangle in the known universe and beyond, when you total up the internal angles, are always totaling to 180 degrees. So what we know is 90 plus 28 plus some unknown, and we'll just call that x because that's what we use for unknown. We know that these three right here, when added together, will equal 180. So let's say we got 90 degrees plus 28 degrees plus some unknown degree. We know that that equals 180 degrees. Well, to find out how much x degrees is, we'll first, let's see, we can just subtract 90 from each side. That's a pretty easy thing to do. So if we subtract 90 from here, then that just goes away, and this becomes 90 because I've kept the balance. So now I have 28 degrees plus the unknown degree equals 90. If I subtract 28 from each side, I keep the balance in check there, and so that means x equals, what's that, 62? 62 degrees? So x equals 62 degrees, and if I wanted to see, well, is this right? Well, I can come back up here and I can plug that in and see what I get. Well, I can get rid of all that. And so if I stick 62 degrees here in my equation, my original equation, then will it equal 180? 90 plus 28 plus 62 does equal 180. So the unknown angle was 62 degrees. Number 8, make a sketch of the coordinate plane, the Cartesian coordinate system, then sketch a circle that has a radius of 1 and is centered at the ordered pair 3, -3. Click on the stop sign. Okay, we're going to make a sketch. Let's see how you did here. Right, it's 3, -3. First of all, I'm just going to draw my x-axis, and then I'm going to draw my y-axis, and so I'll put it over here, because this ordered pair right here, the center, is going to be in the 4th quadrant. It's not going to be in the 1st, it's not going to be in the 2nd, and it's not going to be in the 3rd. It's going to be in the 4th. Alright, so now I just freehand sketch in 1, 2, 3, 1, 2, 3. It's not perfect, but it's pretty stinking close. This is my x-axis, this is my y-axis, and so I go, x is my first number in the ordered pair. I go 1, 2, 3, and then I'm going to go -3. 1, 2, 3. So there's the center of my circle, and it says it has a radius of 1. So I'll go up 1 in this direction, and that point will fall on the circumference of my circle, and I'll go this way in 1, and that point will fall on the circumference of my circle, and I'll go about the same distance over here. That point will fall on the circumference of my circle, and I'll go down a radius of 1 here, and that point will fall on the circumference of my circle. Now I've plotted some points, so it's easier for me to come in and kind of freehand sketch a circle with a radius of 1 located at 3, -3. It's in the 4th quadrant. Number 9, multiply these fractions. Click on the stop sign. Okay, let's see how you did. Multiplying fractions is exceedingly easy. You simply just multiply all the numerators, multiply all the denominators, and then simplify as necessary. So 1 times 3 is 3, and 3 times 4 is 12. So our numerator is 12, and then I come in and I say 2 times 4 is 8, and 3 times 8 is 24, so I have 24. So my fraction is this, but I haven't simplified it yet. Maybe you can recognize that can be simplified to 1/2. But let's take a look at how you would do that. So we have 12 over 24, and 12 over 24, well, you can just factor that. And 12 is the same thing as 3 times 4, and 4 is the same thing as 2 times 2. So factoring this is just 2 times 2 times 3, because 2 times 2 is 4, and this is 3, that's 12. And then we could come down here and I could say 24, that's the same thing as 2 times 2 times 2 times 3, because 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So there's my denominator. Alright, I can cancel this with this. It becomes 1. This is where you'll see it's kind of important that it becomes 1. And I can cancel this with this, and it becomes 1. And I can cancel this 3 with this 3, and this becomes 1, and that becomes 1. So 1 times 1 times 1 is 1, and 1 times 1 times 2 times 1 is 2. Because you see, if these just went away, if they became nothing, if they became 0, I wouldn't have a 1 in my numerator. And I now need a 1 in my numerator. So this is why they don't go away and become nothing when you cancel them. They become 1. So that's how you would simplify this to be 1/2. Alright, number 10. Click on the stop sign. Okay, we're going to divide 7 by 3/4. Well, I've told you other times that all you have to do is flip this puppy over and then multiply. And so the 4 goes into the numerator's position, and the 3 here would go in the denominator's position. And students often say, oh, you flip over the second fraction. Well, you notice that we really don't have a fraction here, unless we were to say, oh, yeah, that's over 1. But you don't flip over the second fraction, you flip over the dividing fraction. That's what you flip over. So this becomes 7 times 4/3. And how do you multiply fractions? You simply multiply the numerators, multiply the denominators. 7 times 4, that's 28. And 1 times 3, that's 3. And so we need to simplify this, if we can simplify this any. And let's take a look at this. Nope, I don't see how I can simplify it. But what we do have is an improper fraction, and I need to turn that into what's called a mixed number. In other words, how many times will 3 go into 28? Well, 3 times 9 is 27, so it'll go 9 times. That'll leave me with 1 left over, and then I'm dealing in thirds. So it's 9 and 1/3 is the improper number, and this is the mixed number, and this is the improper fraction. Okay, they're the same amount. These equal the same thing. If you wanted to check, hey, how am I doing here? Is this right? Just do this. 3 times 9 is 27, plus 1 is 28, and you're dealing in thirds. That's 28/3. Okay, number 11. Click on the stop sign. Okay, let's see how you did. Well, first of all, this is a trapezoid, and trapezoids have the formula for finding their area as A equals B1, the base 1, plus base 2, all of that in parentheses, times the height, all divided by 2. Now, it doesn't matter which one of these you call base 1 and base 2. The bases are just the parallel lines, and so I have these lines here that are parallel. And so it doesn't matter which one I call base 1 or base 2, because all I'm really doing is just adding these numbers. And if I add 4.5 to 6, I get the same answer than if I add 6 to 4.5. So, all right, 6 plus 4.5 is 10.5. And I want to multiply that times the height, which is feet in another direction. So that's times 4 feet, and all of that divided by 2. Okay, 10 times 4 is 40, plus a half is 2, so I'm at 42 feet squared. Divide that by 2, and that's going to give me 21 feet squared, and that's my answer. Number 5, click on the stop sign. Okay, let's see how you did. We'll make a sketch of the depiction below and then reflect. There's the key word. Reflect it across the y-axis. That's another key thing there. This is my y-axis, and I want to reflect it. So I would come in and make a sketch that looks something about like that. And since I'm reflecting it, the circle would be over here because it's as if there was a mirror right here. Number 13. Click on the stop sign. Okay, let's see how you did. Sketch the drawing below and copy the figure across the x-axis. All right, here we have the x-axis, and we're going to make a copy, which means it's going to look just like this, but it's going to be down here. And so let me kind of freehand this puppy like this. So it goes like that, this goes like that, this goes like that, that, and that. That's about as good a sketch as I can make. So that's a copy across the x-axis. Number 14. Click on the stop sign. All right, this is kind of a two-part problem. You got to find the area and you got to find the perimeter. We'll start with the perimeter because that one will be kind of easy. All right, where we have a triangle, and I would encourage you to always make a sketch. See what your triangle looks like. This is 3 feet. Says one of the legs is 3, one of the legs is 4, and the hypotenuse, it's 5. Then it says, what's the perimeter? Well, the perimeter is just the total distance around. That's it. You just add up all the numbers. 3 plus 4, that's 7, plus 5, that'd be 12. So we're talking about 12, and it says they're in feet. So it's 12 feet equals the perimeter. If you got that right, you're doing it right. Good for you. Now we got to calculate the area of this thing, and the area of all triangles is exactly equal into this formula right here. It's 1/2 the base times the height. It doesn't matter really what you call the base, and it doesn't matter really what you call the height. You just have to multiply this number that length times this length, and they're going to be in feet, so I know that it's going to be an area kind of thing. So it's going to be feet squared. So I have 1/2 times 3 feet times 4 feet, and so that's going to be 3 times 4 is 12. So that's 12 feet. And so I have 12 feet squared, because I'm multiplying feet times feet, and that's all divided by 2. If I multiply times 1/2, it's the same thing as dividing by 2. And so I wind up then having 6 feet squared. That's my area. Number 15. Click on the stop sign. Okay, sketch a circle and label 4 main parts. I need 4 parts of this. Well, every circle has a center, and every circle has a circumference, and every circle has a radius, and every circle has a diameter, and every circle has an area. It's a two-dimensional object. Okay, that's center 1, 2, 3, 4, 5. That's 5. So if you got 4 of those, you're doing it right. Number 16, click on the stop sign. Okay, we're adding and subtracting positive and negative integers. So I'm going to make a number line here to kind of sketch this out to talk you through to see how you did. Well, I'm going to start with 10 on my number line, so we'll just make a spot here and we'll call that 10. And then it says I'm going to add negative 10, which means I'm going to go in this way. So I go this way and I wind up at 0. And now I'm at 0. And now it says add 30, so I'm going to add 30. So there's 10, 20, 30. So now I'm at 30. And then it says to subtract negative 7. Take away a negative number. That's the same thing as adding 7 more. So I'm going to come over here and my final answer is going to be 37. Now, taking away a negative thing is a positive thing. Even in your life, taking away a negative thing is a positive thing. The way I remember this, and I've done it since I was a boy, is that if I need this negative, this line right here, to come over here and turn this into a positive, I've used it, so it's no longer here. And so what that means is now I'm adding 7. Taking away negative 7 is the same thing as adding 7. The answer is 37. Okay, number 17, click on the stop sign. All right, let's see how you did. Well, first of all, these are sixteenths. There are 16 little marks between the 0 and the 1, and they're the same 16 little marks between the 1 and the 2. You don't have to learn them all over again. They're the same little marks. It's that way between the 2 and the 3. There are 16 little marks. If there are 16 little marks, sometimes you'll find a ruler that has 8 on there or something like that, or even more. So we can look at this and we can say that's 1 16ths, 2 16ths, 3 16ths, 4 16ths, 5 16ths. So A is 5 16ths, and that cannot be simplified anymore in inches, 2 little marks there. So if I'm at 5 16ths here, that's 6 16ths, 7 16ths, 8 16ths, 9 16ths, 10 16ths. So that's 10 16ths, and I can perhaps recognize that 10 16ths and 5 eighths are the same thing. So that's 5 eighths inches. And so here I am at 10 16ths, 11, 12, 13, 14, 15, 16 16ths. Hey, that's exactly 1 inch, 16 16ths. 17, 18, 19. You could call C 19 16ths, but if you told somebody that, if you said, hey, cut me a piece of wood there at 19 16ths, they'd think you were stupid. So here we are at 1 and 1 16ths, 2 16ths, 3 16ths. 19 16ths is the same amount of stuff as 1 and 3 16ths. And they're inches. So we'll put 2 little marks. That means inches. All right. So if we continue to count, we're at 16 16ths here. We would be at 32 16ths here. So we could say 33, 34, 35, 36, 37. We're at 37 16ths. And again, if you told somebody to cut you a piece of wood at 37 16ths, they'd think you were nuts. But we are at 2 and 1 16ths, 2 16ths, 3 16ths, 4 16ths, 5 16ths. So we are at 2 and 5 16ths inches. If you got them right, you're doing well. Okay, number 18. How many minutes are in 7/8 of an hour? Click on the stop sign. Okay, well, let's see. There are 60 minutes in an hour, and we want to find out what that is, how much is 7/8. So it's going to be less than, 7/8 is less than 1. So it's going to be less than 60 minutes. So we're going to multiply the fractions here, 7/8 times 60 over 1, and 60 times 7 equals 420, and 1 times 8 equals 8. All right, we could do the top in, bottom out on this, but that might be a lot of work, so yeah, let's go ahead and try that. So we do 420, and 8 goes on the outside. We're doing the long division here. 8 will not go into 4, but 8 will go into 42 5 times, and that's 40. And then we do our subtraction, and we bring down the 2 and the 0, and so let's see, 8 will go into 20, 2 times? Yeah, 2 times, and so that's 16, and that leaves us with 4 left over, and 8 will not go into 4. We're at the end here, so we got to add a decimal. And go 40. 8 will go into 40 exactly 5 times. So there are 52.5 minutes in 7/8 of an hour. Does that make sense? This is a little bit less than 1. This is a little bit less than an hour. Number 19. Click on the stop sign. Okay, Thomas charges $10 per hour for his handyman service. If he works 8 to 12 hours per day for the week Monday through Friday, what is the range of his gross pay? All right, we have several things here. Let's take a look at this. The guy's making $10 an hour. Some days he works 8 hours, and other days he works 12 hours, or somewhere in between the two. He works only Monday through Friday. That's 5 days. And what is the range? Range means what's the least amount of money that he's going to make to the most amount of money that he's going to make. And gross pay? Gross just means the total amount of money that he was going to make, instead of, sometimes you get what's called net pay, and net pay is after they've taken out some withholding and some things like that. So how much money would he make if somebody was paying him in cash? All right, let's see. On Monday, let's just take a look at this. Monday, he works either 8 or 12 hours. So he works a minimum of 8, and he works a maximum of 12 hours. And there are 5 days in a week, so let's just multiply that times 5 to get what's the minimum number of hours that he would work for a week. and that would be 40. And if he were to work 12 hours a day every day, then that means he worked 60 hours. So he's going to work somewhere between 40 and 60 hours for the week. Okay, but he's making $10 an hour. So making $10 an hour here, and he doesn't get any overtime with his handyman service. He just gets a straight $10 an hour. So 40 times 10, that's 400. And 60 times 10, that's 600. So he's making somewhere between 400 and 600. So the range is 400 to 600, or that's about a $200 range that he makes. So that's either 400 to 600, least to most, or the difference is $200. Okay, number 20. Let's take a look. Click on the stop sign. All right, let's see how you did. Well, first thing you need to do is that which is in the parentheses, and that which in the parentheses is pretty straightforward. It's just 3 times 7, that's 21. 21, and 6 times 4, that's 24. So we have a fraction here. I'm going to multiply that times a decimal. I could turn this into a decimal and then multiply it, or I could turn this into a fraction. Let's see. Excuse me, I'm going to turn this decimal here into a fraction, and that would be times 37 over 10. Because you see, whatever the number here is, that's my numerator, and however many places I have in the decimal here, that tells me what I'm dealing with, how many zeros I have. So I only have one decimal place, so there's 1 0, and so that's 10. So I'm at 37 tenths. Now, okay, looks to me like I can simplify this one. So 21 is the same thing as 3 times 7, and 24 is the same thing as 3 times 8. Alright, I can cancel 3 with the 3, and so now I have 7/8 times 37 over 10. And that equals 8 times 10 is 80. And 7 times 37, let's see, I have 37 times 7. 7 times 7 is 49. Carry my 4. It's 21, 25. 25. 259 is my numerator. 259. Alright, there's my improper fraction that is the correct answer. However, you might have been instructed to turn that into a mixed number, or simplify that as much as possible. So let's get some room to work here. You can always go get, another piece of scratch paper. Alright, let's see. How do I turn 259 into 80? So that would be 259, my number n, and I'm going to divide that by 80. Alright, 80 will certainly not go into 2, and 80 will certainly not go into 25, but 80 will go into 259 3 times, because 3 times 80 is 240. So we're at 240, and that leaves me with 19 left over at the end, so I'll add a decimal here. So 3 times 80 is almost 259. So it's going to be 3 and some decimal points. And 80 will not go into 19, but it will go into 190. And so let's see, 2 is 160. And that leaves me with 30 left over. 80 will not go into 30, but it will go into 300. So 80 times 3 is 240. Leaves me with, I'm doing some subtraction here, 60. And 80 will not go into 60, but it will go into 600. and it will go 7 times. So 7 times 80, 7 times 8, that's 56. 56, and I have a 0, and that leaves me with 40. And 80 will not go into 40, but it will go into 400. And let's see, 5 times 80 is 400. So 5 times 80 is 400. And so we do the subtraction, we wind up with 0. So our answer is 3.2375. That's the end. You're now ready to try other basic math self-tests. You may contact me at alanmorris@yahoo.com.